Hi there, today I'm going to talk about the partial pivoting process. One reason why I want to talk about it is that it doesn't really matter if you're, in your class and doing, I don't know, solving system of linear equation using the Gauss method or the Gauss-Jordan method, and you're doing it by yourself, with pen and paper, just like this. Doesn't really matter. But if you are, an engineer perhaps, or if you're doing if you're doing calculation using a calculator or a computer, because the system of linear equation or whatever you have to do is very very big and you gotta rely on a computer to do that. You gotta know what I mean by what everybody means actually, by the partial pivoting process. So in order to show you why this is actually important, I have to introduce you with the difference between the number we use every day, and the machine numbers with the finite precision. So basically, these ones are the number we deal with every day. So, and we have many interesting properties that are not even valid with machine numbers. One of those properties that if I, everybody knows that if I do, 3 over 4 times 9 over 65 times 2 over 7 is exactly the same as doing those two first and then multiply everything by this one. I mean, it doesn't actually really matter. You're always gonna get 54 over 1820. And this is, one of the properties that teach you, when you first go to school. Um, but unfortunately is not valid for computers, and it is actually because we're going to rely on a finite set of numbers. So in this case, those are not integers, of course, those are fractions, and therefore we're going to have to display them, rounded and just like this. Since we don't have an infinite precision, whenever we deal with those numbers, we can't actually be sure that doing the multiplication here and then multiply the result by this one is going to be exactly the same as doing this one times, this one times this one. And this is actually a very simple example here, but if you first multiply these two guys and then you multiply by 0.75, you get 0.02925. However, if you do the first one times the second one times the third one, and we expected it to be exactly the same, but not, you get in fact a different number, so 0.029601, which differs from the one we found doing this. So since we actually expect those things to be like this, I want to talk about the partial pivoting. So let's suppose that you are dealing with I don't know, a simple system of linear equation. So you basically have, well, let's see, matrix as we always do. So let's start with our matrix 0 point, I don't know, 0001. Then you have negative 7, 0, 1, 2, 2.9, 6, 1, 7, negative 1, negative 3, 1. And then you have, I don't know, another row 1, 1, 2, 1. So this is our magic say. I already show you how to solve the linear system of equations. So with the Gauss-Jordan method. So check the video if you don't know what I'm talking about. But today I'm just gonna talk about the partial pivoting process. So basically, this is our matrix. Then we have our vector x with a component x, y, z, and w, which is equal to c, which is, I don't know, like 3, 2, 1 0, and this gives us our system of linear equation. So we basically have 0.0001 x minus 7y plus w. Then we have a equal to 3, of course. And then we have 2x plus 2.9y plus 6z plus w equal to 2. And then we have 7x minus y minus 3z plus w equal to 1. And then we have x plus y plus 2z plus w equal to 0. So this is basically our system linear equation. Now, before solving it, we're not dealing with fraction, we're dealing with those numbers, and you gotta have to expect that the calculator, so a computer, is gonna have to deal with those numbers. So what we want to do, instead of starting with the Gauss-Jordan like we always do, is actually to bring the we're using the we're basically checking the rows, the first column of those rows, and we actually are checking which value is bigger in module. So basically the biggest absolute value between those guys, and therefore our first step will be to actually exchange, will be, let me just rewrite it because I don't have space. Is just 1 1 2 1. So our first step will be to exchange the first one basically with the third one. Exchange, yeah. So basically, the first one with the third one. So basically, we're gonna have 7, -1, -3, 1. Then we have 2, 2.9, 6, 1. And then we're gonna have 0.0001, -701, and then we have 1, 1, 2, 1, and then we're gonna start. So this is actually important because this is called the partial pivoting process. We're trying to do is to avoid to actually divide or multiply and stuff like that, and deal with numbers that are very close to 0. So if it's 0, the algorithm is gonna stop. If it's close to 0, it may stop as well. So we're trying to avoid to deal with these kind of numbers. So this is actually the partial pivoting process. We basically check the value of those rows. So of the on the first column of all those rows, and we check the highest absolute value between those. So let me. Well, this is actually partial pivoting. If it was, the total pivoting, we would have checked also the not just those, but also the full matrix basically. So not just the very first pivot. So basically, if we have, I don't know, another matrix like I don't know, if we have a matrix that is already fine, like I don't know, 1 1 1 0 0.0001 3 0 1 1, this matrix here is already fine because we're only gonna check the element of this column, and one is actually the highest element, so we don't have to do partial pivoting. Is this one is actually fine. If we have another matrix like I don't know, something like, well, 0, 1, 1, -2, 0, 7, and then we have -3, 0, -2. In this case, what we want to do is to bring this -3 here, because -3, the absolute value of -3 is actually 3, and therefore we want to bring this 3 here because it's higher. So we're basically going to exchange the first one with the third one, and then we're going to do -3, 0, -2, -2, 0, 7, and then 0, 1, 1. So as I said, it doesn't really matter whether the number you are exchanging your number with is actually negative and so on. What you want to do is that you want to try to avoid to divide or multiply and deal in any way, shape, or form with 0 or a number close to 0. So you basically take the highest number among those in absolute value, and you basically bring it to the very first position. So another example, I don't know, if you have 0, I don't know, 1, 2, 0, 7, and then you have, 7 looks bad, 7, 0, 3. Well, in this case, again, you basically want to bring those guys up here. I'm basically going to exchange the third one with the first one. And I'm basically going to get 703. The second is going to stay the same, so -207. And then you have, well, 011. There we go. And so on. So basically, this is what you basically do with the partial pivoting. It's actually pretty straightforward, but you gotta do it. You can't just run, the algorithm in a calculator if you have a matrix like this without doing partial pivoting process, because otherwise you're gonna hit 0 at the very beginning, and dealing with 0 or a number very, very close to 0 in a calculator is actually pretty bad. So don't do it.